Hi, students. In this lecture, I am going to discuss problems based on spherical mirrors. Let us see first one. See the question given. A point-sized real object is moving with a constant speed of 1 meter per second towards the pole of a fixed concave mirror of magnitude of focal length is 30 centimeter along the principal axis. When the object is at a distance of 20 centimeter from the pole of the mirror, then the speed of the image is. So see the question carefully. Given speed of the object 1 meter per second and mirror is not moving, and given focal length 30 centimeter, when distance of object is 20 from the pole of the mirror, we have to find speed of the image. Let us see how to solve it. Right, first note down the given data. This is now mirror, which is stationary. Its focal length is given. That is now 30. Right, focal length is given 30 centimeter. Distance of object, given its velocity 1 meter per second, and at one instant, its distance from the pole, it is given as 20. So velocity of object is given. This is object. So we have to find velocity of image. Let us see how to find velocity of image. Let us do one thing here. Let us take the principal axis as x-axis and normal to principal axis as y-axis. So velocity of object is given. We have to find velocity of image. See from mirror equation what we can write. 1 by f equal to 1 by v plus 1 by u. We want now distance of, we want velocity of image, right? So here you can see u is the position coordinate of object. That is with respect to the pole. Okay. Now if you differentiate that, we are going to get velocity of object with respect to the mirror. Or I can say it is x component of velocity of object with respect to mirror. See, first of all, differentiate this. Since f is a constant, derivative 0 minus 1 by v square, it is dv by dt. Next, minus 1 by u square, du by dt. Now from this, see what is the value of dv by dt. dv by dt is equal to, it is minus v upon u whole square into du by dt. So first understand what is dv by dt and what is du by dt. Okay. So in this du by dt, rate of change of position coordinate of object, that is giving us velocity of object with respect to mirror, and that is the x component. See carefully. Velocity of object with respect to mirror along x-axis. Or you can say x component of velocity of object with respect to mirror. Okay. In this problem, it has only one component, that is along the principal axis. That means along x-axis. Okay. Next, coming to dv by dt. dv by dt. That is giving us velocity of image with respect to mirror along x-axis. Means along the principal axis. Okay. Now using these 2 points, let us see here. Since mirror is stationary, since mirror is stationary, velocity of object with respect to mirror or velocity of object in ground frame both are same. So I am writing here velocity of object with respect to mirror along x-axis, that is 1 meter per second. Direction along positive x-axis. Next, we have to focus when its distance is 20 centimeter. At that instant, velocity of image how much? Okay, then see what we are writing here. Velocity dv by dt, that is velocity of image with respect to mirror along x-axis. Okay, that is equal to minus, I am writing in the place of v by u. We know magnification is equal to minus v by u. Okay, here we are having v by u whole square. So I can write this as minus v by u whole square because it is a square, right? Whether writing v by u whole square or minus v by u whole square, both are same. So in the place of that, I am writing here f upon f minus u. Okay, f upon f minus u. Okay, whole square into velocity of object with respect to mirror along x-axis. Okay, now just substitute values in this in the place of f. Since it is now concave mirror, it is given focal length is 30. Then what is the coordinate of focus? That is minus 30. So minus 30 upon minus 30 minus u value minus 20. Okay, whole square. And this value given how much? 1 meter per second. Okay, into 1. Then say what we get? Minus of minus plus. Minus 30 plus 20. Minus 30 plus 20 minus 10. Minus minus gets cancelled. It is now 3 by 30 by 10. It is 3. 3 square 9. It is now minus 9 meter per second. And see meaning of negative. Velocity of object with respect to mirror along x-axis. It is along positive x-axis, object velocity. With respect to mirror, image velocity minus 9. That means image is moving along negative x-axis. Its direction is along negative x-axis. Modulus value 9 meter per second. Okay. Like this, we can solve the image velocity. Okay. This is what we have to keep in mind to find the exo component of velocity of image with respect to mirror. Right. See next problem. See the data given. A police inspector is chasing a thief who is running away in a car with a speed 3 meter per second. So thief is running away in a car with a speed 3 meter per second. The speed of police jeep is 12 meter per second. Then the speed of image of police jeep, condition is speed of image of police jeep as seen by the thief in the rear view mirror. Remember here, rear view mirror means it is convex mirror. Okay. When the police jeep is at a distance of 30 meter, given value of focal length of rear view mirror is now 15. Distance is given 30. Okay. So we have to find speed of image of police jeep as seen by the thief. As seen by the thief means thief is in the car and car's rear view mirror is now we are seeing in that mirror. That means we have to focus now with respect to the thief. What is velocity of image of the police jeep? Right. So first note down the given data. Focal length 15, distance 30, thief velocity 3, and police jeep 12. Now see carefully. First of all, note down the given data. This is a mirror, or you can say rear view mirror of the car, right? In which the thief is there. For that mirror, focal length given 15 centimeter, distance of jeep. Now that jeep is the object that has given 30 and jeep's velocity given 12 meter per second and thief is moving away from the police with a velocity 3 meter per second, right? This is now given data. We have to find velocity of image of the jeep, okay, with respect to mirror. That is how much, right? If you observe carefully, focal length is 15, distance is now 30. That means police jeep is now at center of curvature. At center of curvature means, wait. One mistake I have done here. That is, mirror is now convex, right? Rear view mirror. It is a convex mirror. So let me make it as a convex. It is a convex mirror. Right. Now see what we have learned. If we take the principal axis as x-axis, we have learned velocity of image with respect to mirror along x-axis is equal to minus v by u, or writing f upon f minus u whole square into velocity of object with respect to mirror along x-axis, right? Now just put values in this, nothing else. Minus f value. It is a convex mirror. It is a positive. F is positive. Again, F15 minus U is negative, right? Because we are taking now right of the pole positive x-axis, left of the pole negative x-axis. Because this is object, light is traveling towards right side and we are taking the direction of instant light ray as positive. It is minus 30. Minus 30. So you should be very careful while taking the sign convention. Velocity of object with respect to mirror along x-axis. This is in ground frame with respect to mirror. I will write here velocity of object with respect to mirror along x-axis. That is now 12 minus 3, that is 9. Direction is along positive x-axis. It is 9. 15 minus of minus plus 15 plus 30 45 all square into 9. This is 1 by 3, 1 by 3 square. It becomes minus 1. Minus 1 meter per second. Means with respect to the mirror, image appears to move along negative x-axis with a speed 1 meter per second. Okay. So in this key point is that rear view mirror. It is a convex mirror. So we should be very careful there. And remaining is directly calculation part. Right. See the next one. And next also almost same kind of question, right? Just values are different. Let us see once values given 2 centimeter per second. This is a 10 and this also 10. Okay. So mirror is now convex. Okay. 10, 10. This is 10 centimeter per second. This is 2 centimeter per second. Object velocity, convex mirror. Right. So we have to find velocity of image at this instant. Right. Let us see. Almost same question, just values different. First note down the given data, given convex mirror. It has a focal length 10 centimeter. Its velocity 2 centimeter per second. Object velocity given 10 centimeter per second. Its distance at that instant given 10. Okay, at this instant we have to find velocity of image. Okay, right. Now what else we want? Okay, first write down velocity of object with respect to mirror along x-axis. So we are taking the principal axis as x-axis. This is a 2 and this is a 10. So this becomes now 8 centimeter per second direction positive x-axis. So with respect to mirror, velocity of object is 8 centimeter per second. So we have to find velocity of image in ground frame, right? Now see how to solve it. Velocity of image with respect to mirror along x-axis is equal to minus f upon f minus u whole square into velocity of object with respect to mirror along x-axis. So put values in this one minus f value. F is convex mirror, so f is a positive 10. Again positive minus u value. U value is minus 10. It is minus 10 whole square. This is now 8. See how much we get? 10 minus 10. This is 20. 10 by 20, 1 by 2. 1 by 2 whole square, 1 by 4. So 1 by 4 into 8. That is now minus 2. Minus 2 centimeter per second. This is velocity of image with respect to mirror along x-axis, right? But we want to calculate in ground frame. In ground frame, see how to solve it. This is velocity of image minus velocity of mirror both along x-axis, that is equal to minus 2. From this, velocity of image along x-axis is equal to minus 2 plus velocity of mirror along x-axis. And that value how much? It is 2. So it is now minus 2 plus this is 2. That is equal to G. So first we are calculating with respect to mirror, then we calculate in ground frame. Okay. So I hope you got a clarity. Let us move on to next problem. Okay. See the question given. Image of an object approaching a convex mirror of radius of curvature 20 meter. Given radius of curvature from this focal length is, it is f equal to r by 2, means focal length is 10. Okay. Along its optical axis is observed to move from 25 by 3 meter to 50 by 7 meter in 30 seconds. What is speed of object in kilometer per hour? So asked in 2010. So first of all, we have to focus the given data, right? So it is given that image moves from 25 by 3 to 50 by 7, right? Then we have to find speed of object. Let us see now. Right. First note down the given data. We have to calculate velocity of object. Okay. And given that image moves from 25 by 3 meter to 50 by 7 meter, time taken for this is 30 seconds. So here what I am doing is, and we are given radius of curvature is 20 meter. From this what we can write? F equal to r by 2. That is now 10 meter. So here what I am doing is, you can take it as this is V1, this is V2. Corresponding to these two, find out positions of object. Okay. Let us do now. This is I'm taking it as V1. This is V2. Correspond to this U1 that we have to calculate. And for this U2 corresponding one, we have to calculate. Then we can take a change of these two by this 30 gives velocity of object. Okay. Let us now take mirror equation 1 by f equal to 1 by v plus 1 by u. Right. Substitute values. V1 25 by 3. So 1 by f, that is now 1 by 10. That is equal to 1 by v. It is 1 by 25 by 3. 25 by 3. 25 by 3. Okay. Next, plus 1 by u. That is u1. Right. See what we get. Since object is now real, we should take a negative value. Otherwise, we get along with the sign. Right. So 1 by u1. 1 by u1 is equal to, see what we get here, 1 by 10 minus 1 minus 3 by 25. That is equal to, that implies u1 equal to 25 into 10. This is 25 minus 30 means minus 5. Check it once. 25 minus 30 minus 5. Here 5 times. It is minus 50. What is minus 50? It is the position coordinate of object. Okay. Negative indicates it is a real object. Right. Next, in the same way, again take mirror equation. Then see what we get. 1 by u2 is equal to 1 by 10, 1 by 10, 1 by 10 minus 1 by v minus 1 by 50 by 7, 50 by 7. That implies u2. See how much? u2 value. 50 into 10 upon 50 minus 70 minus 20. Okay. Right. See what we get here. 25 minus 25 meter. Okay. Initial value minus 50. Now it is minus 25. That means it is moving towards a pole, right? See carefully. I will make a diagram here. This is now, wait. This is a convex mirror, right? It is a convex mirror. Convex mirror. Right is positive x, left is negative x. We got u1 minus 50, u2 minus 25, moving towards a pole. So distance covered how much? Minus 50 to minus 25. Distance covered by the object 25, right? That means velocity of object is equal to, or if you take a speed, okay, modulus of velocity speed, that is equal to 25 meter in 30 seconds. That is giving us 5 by 6 meter per second. And this we want to convert into kmph. Then multiply this with 18 by 5. Okay. To convert into kmph. 6 and 18, 3 times, right? This is now 3 kmph. Is a point here. So just finding the position coordinates of object at both these instants. Once we know that, we come to know distance covered. It is distance covered by object in that 30-second time interval. That gives us velocity of object, which is now 3 kmph, right?